This question is from JEE Advanced 2023 and it's very easy question based on standing waves on stretched strings. Question is, a string of length 1 meter and mass 2 into 10 to minus 5 kilogram is under tension. When the string vibrates, two successive harmonics are found to occur at frequencies 750 Hz and 1000 Hz. The value of tension is dash Newton. तो स्ट्रिंग में कितनी टेंशन है हमें वो बतानी है. दो सक्सेसिव हार्मोनिक्स की फ्रीक्वेंसीज हमें गिवन है. तो स्ट्रेच स्ट्रिंग्स में जो स्टैंडिंग वेव्स बनती हैं उसमें सारी हार्मोनिक्स प्रेजेंट होती हैं, ओड एज वेल एज इवन, राइट. तो हार्मोनिक्स मीन्स मल्टीपल ऑफ फंडामेंटल फ्रीक्वेंसी. सो फंडामेंटल फ्रीक्वेंसी, let us denote it f naught, is given by v upon 2l. Fundamental frequency is the smallest frequency at which string can vibrate. So v क्या है? Speed of transverse wave on stretched string. L is length of string, right? F naught fundamental frequency. As I said, successive harmonics में जो frequencies हैं, they will be multiple of if one is nth multiple, if it is nth multiple, this will be n plus 1th multiple of fundamental frequency, right? So n into fundamental frequency is 750 Hertz and n plus 1 times fundamental is 1000 Hertz. So n plus 1 f naught minus n f naught is 1000 minus 750. So we get f naught. Fundamental frequency is 250 Hertz. सक्सेसिव हार्मोनिक्स की फ्रीक्वेंसीज को अगर हम सब्ट्रैक्ट कर दें ग्रेटर में से स्मॉलर को, तो वी गेट फंडामेंटल फ्रीक्वेंसी ऑफ स्ट्रेच्ड स्ट्रिंग. ओके, सो 250 हर्ट्ज इज द फंडामेंटल फ्रीक्वेंसी. V is fundamental frequency into 2L. Fundamental frequency is 250. 2L is 1 meter. So speed of transverse wave on this string is 500 meter per second. Speed is given by square root of tension upon mu. Mu क्या है? Mass per unit length. Mass per meter length of the wire, which in this case is going to be 2 into 10 to minus 5 kilogram because length is 1 meter. So mu here, mu will be mass divided by length. So mass is 2 into 10 to minus 5 kilogram. Length is 1 meter. So mu is 2 into 10 to minus 5 kilogram per meter. Now अगर हम इसको स्क्वायर करें तो we can write tension upon linear mass density mu is equal to square of speed of transverse wave on the string. So T is V square into mu. So tension is V square into mu. तो V is this. इसको स्क्वायर करेंगे तो हमारे पास आएगा 25 into 10 raised to power 4. Mu is 2 into 10 to minus 5. So we have 50 into 10 raised to power minus 1. So tension is 5 Newton. So tension in this string is 5 Newton.